Okay, I think we're going to get started. Thanks for coming at least to the first class of Interaction Techniques. I'm Brad Myers, and this is a brand new course that we're trying out for the very first time. The course, since we don't have any PhD students, the master's students and the undergraduates will do exactly the same work, so that makes it a lot easier to administer. And a lot of people registered for the wrong number, but Indra, the secretary, the administrator, just put you in the right place. So hopefully everybody got into what they wanted. The course is Mondays and Wednesdays, 1:30 to 3 here. If we get up, originally I was, worried that there'd be an awful lot of people who would want to take the course, so we got this really nice big room. If a bunch of you guys drop out and we end up being smaller, we might end up moving to a smaller room. Right now it's kind of the perfect size, but we'll see how many people actually stick it out. There's still a bunch of people who are on the waiting list because they have 99 units, and so I presume you kind of people that registered for 99 units aren't really planning to take all those. So hopefully you'll decide to take this course, but if not, we might move to a littler room. Since this is the first time I'm teaching this course and there's a lot of material that I think will be interesting for the community at large, I'm arranged to have it videotaped. And the videos will be ready a few hours after lecture in case you want to go back and review stuff. It's also available if you're out of town. A couple of people emailed me that they had emergencies and they weren't able to get back in town. Somebody broke his leg. So it's also available for you, to review if you need to catch up. It's not intended to be a replacement for being here. We're going to have a certain amount of the grade based on your in-class participation. We're going to have in-class exercises. There might be a few quizzes in class. You're not, basically everybody's required to come to all the lectures, and the videotape is basically just for, extra review if you need it. Okay. Most of the material is up on the public web. So we're going to use Blackboard basically only for homework turn-ins or secret stuff that you guys need that we're not really allowed to give people in general. So you'll find, for example, I copied some pages out of a book and put it on Blackboard because I didn't want that on the public web. So that's for you guys. But the nice thing about having this on my personal website is it'll be there forever. So if in 3 or 4 years you realize you'd love to see some of this material again, it will be there basically forever. And if I do this course again, I'll use it, with a different number. And so the number that you're taking, it'll actually stay there forever, pretty much the way it is at the end of the year. So hopefully everybody's found it. Looks like this. And I've been updating it pretty regularly, and I will probably continue to do that. So you should come back here often. The schedule is in tremendous flux. We're trying to figure out the content as we go. And notice that each day has some required readings and some recommended readings. And the required readings you're supposed to do as homework in advance of the lecture. I tried to focus on videos as much as possible. A lot of this stuff has some pretty interesting videos. And also kind of more or less academic articles, kind of more fun articles from magazines rather than kind of very academic articles from conferences. So this is Interactions magazine. This is an article I wrote a few years ago about the history, kind of just exactly the topic that we're talking about. And so basically you're required to read this and watch this video and skim through these articles before Wednesday's lecture. And so if something's in the required readings, then there is some chance that there'll be a little quiz on the content before lecture, just to make sure everybody's motivated to actually go ahead and do it. This is a really fun and amazing demo from '64. You'll be amazed at what was happening all the way back then. And this, as I mentioned, is a copy out of a book, which has some really interesting interviews. And this is almost 100 pages, but about half the pages are pictures. So it's really only about 50 pages, and you really only have to skim this one, but you should definitely read these in fairly detail. And if you've seen them before, you should probably read them again just to make sure you remember what the content is. And as you go down, you'll see it gets a little more vague, like I don't have readings for most of the later stuff yet, but that'll be filled in as we go. And this will also be where I'll put the video links. So directly below the title, there'll be a link to the PowerPoint slides I'm using and a link to the video. And so this will be where you'll go to, click on those links if you want to review or see what we covered. Homeworks. Oh, yeah. So going back to the course's main page, I've added a homework and a homework policy. And so the idea of the homeworks is we're going to have a really fun final project that people will do in small groups. But before we get there, we're going to look at 4 different classes of interaction techniques. And the first one, which you guys will start on Wednesday, and we'll assign different things, is pointing devices like a mouse or a touchpad, or you just using your finger on a tablet. That'll be the first one. The second one is different kind of menus. So there are regular menus like the Mac that's at the top of the screen, and there are pop-up menus like right-click menus, and there's round menus called pie menus. There's lots and lots of variations on menus that we'll talk about, and we'll be studying how well those work, comparing different kinds. Then we'll look at scrolling, how to move around in a big document. There's a conventional scroll bar. You could flick your finger like on phones. Lots of other techniques. You could use arrow keys. And then finally, text entry. You could use a conventional keyboard. It's pretty obvious, but there's also ways to do it on phones, and there's a bunch of novel ways. Anybody have a Samsung phone with a swipey thing? It's actually called Swipe, right? And so that's pretty cool. You can just swipe your finger around without actually tapping on keys. So there's a bunch of novel techniques. My colleague Chris Harrison just invented a new text entry technique for watches that he published last year. You can imagine it's hard to fit a keyboard on a watch, and so we had a technique for that, and so forth. So those will be the first few weeks. Each one's about 2 weeks for the assignments, except the first one, we're 3 weeks because it's going to take us a while to get started. And then the second half of the term, we'll mostly be focusing on the projects and progress reports along the way. In terms of the policies, there's a pretty extensive document that talks about all the policies and cheating. You're not allowed to collaborate on the first homeworks. Obviously, you're going to be collaborating on the final homeworks. The first homeworks are each worth 10 points. So that's 10 points out of 100. So if you just blow off the first homework and never do it, then the highest grade you could possibly get is a 90. So it's pretty easy to do this math. In the course I taught in the fall, somebody skipped the first 3 homeworks and then was surprised they flunked the course. But I said, look, it's been here since the beginning. If you take off 30 points out of 100, you're going to start with a 70, and there's no way you can pass. So it should be pretty straightforward. The late policy is pretty generous. The homeworks are all due right before class. So you don't have a good excuse for skipping class. And immediately at 1:30, it's 10 points off, 1 letter grade. And then it's 10 points each lecture after that, right? So if it's due on a Monday and you don't turn it in on Monday, but you turn it in before class on Wednesday, it's 10 points. After Wednesday, it's 20 points and so forth. And there'll be a deadline at the end of the term where it's too late. But other than that, 10 lectures late, you would still get, or 9 lectures late, you'd still get 10 points. So should be pretty straightforward. We're asked to put this enormous block of stuff about cheating and plagiarism and all these other kinds of things across all the HCI courses. This is the standard boilerplate along with the new university policy. So we're just required to put that on all of our courses, just so there's no ambiguity. Okay. And if there are any readings that are CMU only, like the ACM Digital Library, then you need to be on campus to access those, or using the wireless network here, or else using VPN if you know how to do that from home. Most of them I think are on in the public domain that you can just get to, but if not, then you might need to be on campus. Okay, this is me. So as I said, I'll put these slides up on the web, so if you need to refer to them, you can get to this information. My secretary turns out to also coincidentally be the course administrator for HCI, Indra Zaghetti, and her office is in the corridor, and she knows how to fix up things. I haven't picked a time for office hours. I probably will, but Jeff, our TA, whoops, where'd he go? Oh, he's there. Jeff, our TA, is here in the front, is a PhD student, and he has office hours. We figured they'd be on Wednesdays directly after class. If there's some reason that should be some other time, let us know. But all the homeworks are due on Mondays, so it seemed like Wednesdays would be the most useful. And obviously, you don't have any questions yet, so you can start looking at stuff for Wednesday. And he's doing it in his own personal office. Don't you have office mates? Is that not a problem?
If they move, if so, I'll let you guys know.
Yeah, so you can walk, but anyway, he's available. So why am I teaching this course? It turns out I've been doing this kind of work for a really long time, and I've kind of always been interested in history. When I was at MIT, I was at what was then called the Architecture Machine Group, which is now called the Media Lab, and I worked on some of the very early interactive systems they have there. One was called Spatial Data Management System. I was at Xerox Palo Alto Research Center, Xerox PARC, in the late 70s, which was well before they were inventing the star, when they had the Alto machine. I'll show you some funny old pictures of me back then. And so, I was around using all these kinds of interactive technologies before anybody else was. I went to work for a startup company in Pittsburgh, actually, called Three Rivers Computer Company, and built one of the first commercial window managers that was ever out there, well before the Star and the Apple stuff. So it was 80 to 84. I made a bunch of innovations that no one had ever done before that influenced later things, like we were the first people to have progress bars in icons, which is kind of like they have progress bars and taskbars now. I put the icons together in a window, so a bunch of inventions that we did. Then in '84, I noticed that the company I was working for, PERC Systems, they'd renamed themselves, was going out of business. They really were never going to make it. So I figured I'd go back to school. So I went to the University of Toronto and worked with Bill Buxton, who's a pretty famous guy at this point, to get my PhD. And at the time, I worked on things like two-handed user interfaces and progress bars. And again, this is 84, so pretty big time in terms of when stuff was being released. Then I came here in 87, 88, after I finished my PhD, and did a bunch of interesting stuff. Right away, I built this video called All the Widgets, which you're going to be assigned, which is a 2.5-hour video that has this long history of how things like scroll bars and interact buttons and dialog boxes came about. And I wrote this history article. Actually, that was inspired by somebody coming up in a meeting I was at and saying, oh, we don't have to fund research into HCI because Apple will do everything. And so, I knew that Apple had really not invented most of the interaction techniques people are familiar with. They certainly invented a bunch of them, but not all of them. And so the point of this article was to try and emphasize how much of this invention came from a wide variety of places, many of which were universities. And so this is the article you're required to read for next week. And not to give you the impression that all of my great work was done in the 80s. A few years ago, my student Jake Wobrock and I invented a new text entry technique, which we'll talk about when we get there. And so, we're still working on these kinds of, new interactions, up to now. And so, to the extent that any of you guys come up with a cool new interaction technique as part of this course, I'd definitely be excited to help you, publicize it, make papers out of it, get a patent on it, whatever you want. And personally, I do a lot of intellectual property consulting to companies all over the world, big companies that you've heard of, like Apple and Google and Facebook, helping them defend themselves against other companies and trolls and stuff when they invent things on user interfaces. So I'm really interested in this topic, and I was kind of surprised to discover that there's really surprisingly little information out there about this kind of history. And so that's one of the reasons I thought, it'd be fun to try and collect this information together for this course. So when designing this course, I wanted to try and make it so it was accessible to a wide variety of people. So there's no programming required. So there's kind of two different ways to do the final projects. The intention is that people who are interested in programming and want to invent a new interaction technique, program it up and see if it works. That will be definitely one of the things that we can do. But also you could, think about doing something that's more history focused, actually recording or talking to people about, where some of these techniques came from. Originally, I was going to only let people in who were in the minor or major of HCI, but there weren't enough of you guys who wanted to take the course, so then I opened it up to everybody. So if you don't have any background in one of the standard HCI methods, you should probably try and read up on some of those information, although we're going to probably cover most of what you need in lecture, so it probably won't be that much of a problem if you don't have that background. Anybody here who doesn't have any of these courses? A couple people? Okay, it's a reasonable number. All right, so we'll take that into account with what we are trying to cover. So in order to help plan this course, it turns out CMU has a division of people to help plan courses called the Everly Center for Education or something, and they have a bunch of people there who are really well practiced in designing courses. So I met with them a few times, and they strongly encouraged me to focus on the educational goals. So Jeff and I and the guy from the Everly Center wrote these down, and we're going to try and make sure we focus on these in all the homeworks, and actually copy and paste these into the first homework, as you'll see. So the goal of this course is to take a more, scientific, academic approach to the designing of interaction techniques. So what are the design issues regarding interaction techniques? So you should be able to think about the trade-offs. Why would you design it one way versus another way? How would you decide what would be important to think about when you're trying to design interaction techniques? Given us some requirements or some thoughts about something needed, then you should be able to design an interaction technique from scratch, putting together the pieces that we're going to talk about. You should know how to evaluate an interaction technique. So if somebody was to say, oh, this is a brand new way of pointing at things and it's much faster, then you should know how to do a test to tell if that's really true. Or if they're saying it's really faster for little kids, even though it might be slower for old people. Or this is a way that's much better for phones but worse for laptops or whatever. So you should be able to think about these trade-offs and do the appropriate tests to know whether they're true or not. And then, because we're going to be focusing a lot on the history of these things, it's important that you know kind of where things came from. Is there a reason that something is done the way it is now? Why do the scroll bar arrows point one way? What happens when you click in this part of the widget, and why does it do that? And if there's a good reason for doing it that way, and you think in your system you want to do it a different way, then by having this background, you can make a more informed decision about the trade-offs, about why you would do it one way versus another way. And so if you want to do it a new way, you really kind of have to know the old way in order to know, whether you're ignoring an important requirement or you realize that that requirement is no longer valid. So if looking at the schedule, and going back to the schedule, today's kind of an introduction. Then I have a lecture about history. You really can't talk about the history of interaction techniques without talking about the history of computers. So we're going to go over that really quickly. Then we, on Martin Luther King Day, which is next Monday, there's no classes in the afternoon, so we won't have class. And then on Wednesday, Jeff is going to cover techniques for studying interaction techniques. And these are a little bit out of order because we wanted to give you the right material you need to do the first homework. Right? And so we kind of wanted to teach you this material because then you'll be using this information as you're doing the first homework. And then talking about the mouse. And then I'm going to have another history, which I originally put next to the first history, but then we realized that we wouldn't be telling you how to do the homeworks until after you were supposed to turn them in, so that didn't seem fair. So talking about the mouse and how the mouse got to be the dominant pointing device, talking about handheld devices, and there's a long history of different approaches that have culminated in today's smartphones and tablets. So, what's the whole history of that? And that'll be later. Some of the lectures I'm calling deep dives, just to be kind of cute. And the idea is that it's focused on a particular interaction technique. So on Monday the 3rd, we're going to talk all about desktops. Icons, where they came from, different ways of organizing windows, window managers, overlapping windows. Windows 1.0, Macintosh 1.0, what came before it, things like that. And then we're very lucky to have Larry Tesler giving a guest lecture by Skype from California. He invented a bunch of really important interaction techniques. He is the person who is attributed, everyone agrees, attributed with the invention of copy and paste. Think about the influence of that, right? He invented the idea of cut, copy, paste back in an editor at Xerox PARC in the 70s. Now, virtually everybody in the entire world uses this technique that he invented. He also went to work for Apple and worked on the team, on the Lisa team that invented the pull-down menu from the top of the window. That's on that, and a bunch of other things that are equally or quite influential, maybe not quite to the same level. So a very important person. And I'm hoping to have a few other guest lectures. I've talked to some people and they've tentatively said they were vaguely interested, but nobody's confirmed yet, and so that's still pending. We're going to talk about menus, selecting objects, scrolling, then the past to future are basically the same as deep dives, except that they are stuff that people are still researching a lot. And so there's still a lot of work on text entry. There's still a lot of work on 3D interfaces and media spaces, like the Kinect and things like that, where you can wave. Game controllers and consumer electronics, people with disabilities, physical gadgets, and so on. Gesture recognition. And it gets a little vague near the end of the course. I think these are the right interaction techniques to cover, but I'm certainly very interested in your feedback. If there are topics that you are interested in that aren't on this list, or if there's topics on this list you think would be really boring, definitely let me know. And don't be shy, because as I said, I haven't prepared any of this material yet. It will be really easy to change now. Be harder to change after, later. The CHI conference is the last week of class. Anybody else going to CHI? Okay, so I'm planning not to have class that week. The final projects, you'll have to present them in class before CHI, okay? But you don't have to have the final presentation, the final reports until, last week of class. So, you pretty much have to be done in time to give your reports before CHI, but, all the final writing and stuff you can turn in at the end. My thought, if we go back to the homework list, is not to have a final. And so I didn't leave any points for a final. This is my thought on terms of the distribution of points. If somebody was really excited about having a final exam, let me know. But this is my current thought. We will have a midterm, since all the beginning work in the project is individual, and just to give you a sense of what you're, how well you're doing before we get very far in. Okay, we went through that. Oh, somebody asked about taking it pass-fail, and that's fine. If you need me to sign something for your program, that's fine too. If you're, taking this as an elective and it's okay with your program. And if you want to just sit in the class and audit it, that's fine as well. There should be plenty of room. So the first homework, we're going to do a pointing task, and Jeff has done a great job of re-implementing this click test. So imagine you have to click back and forth. So click on the green bar, and you click on the green bar, and then it moves to the other side. Right? And you can imagine it's harder to click on them when they're further apart and when they're skinnier. And so the skinnier they are, the harder they are to click on. And imagine you're trying to do that on your phone. Clicking on really small targets on the phone is pretty hard, versus using a mouse, which is pretty easy to click on things, versus a giant display. Imagine this was a display and I could just, click on things. So we're going to have everybody in the class do at least 2 devices. So probably everybody has a mouse, and probably everybody has a phone. And I'm wondering if people have anything else that's of interest. So does anybody have an IBM laptop with a red pointing stick in the middle? So if I don't mess things up. So I have an IBM, and there's this red stick here in the middle, which is invented by a guy named Ted Selka, who actually works at CMU West. Does anybody in the class have an IBM? Oh, good. 1, 2? Okay. So you'll use the IBM pointing stick, because I definitely want to include that. Does anybody have access to something like a smartboard or a giant touchable TV or anything like that that's a great big display that's touch sensitive? No? What? Oh, okay. Well, that'll be good to use. I mean, it's pretty much the same as having a tablet machine. But yeah, I mean, so there are wall-sized touch displays that would be fun to test if anybody has access to that. Does anybody have like a Wii controller that they can use to click on web pages? That, where you can bring up. They might have a smart TV or something where you can bring up that web pages on your TV at home. With a controller, game controller of some kind. Okay, so those are some other things that might be fun to try if anybody can think of, So we'll, on Wednesday, during class, we'll assign everybody. And hopefully we can get some nice distribution of, everybody is not doing exactly the same thing. And, if you have an Android phone or iPhones of different sizes or a tablet, we're going to try and get kind of a distributed set of people doing a variety of things. Obviously, there's not enough devices for everybody to do something different, so we'll just do a collection of them. And what we're going to have you do, and the homework is not quite finished yet, so I haven't actually put it up, but as a sneak peek, you're going to basically do this software that looks like the pictures I showed you, where you're going to tap a bunch of times, and you're going to run that on 3 people, yourself, someone who's like you but not in the class, so a friend, can be in your program as long as they're not in the class, and then someone who's not like you, so a little kid, a grown-up, you can use a secretary, somebody who doesn't know programming very well. So just, to give you a sense of how to run subjects in an experiment. And then you're going to write a report that talks about what you did and describes it with respect to the historical record. And so this is kind of where I'm referring back to those learning goals that I mentioned, talking about the design issues, talking about the appropriate tests, talking about the historical progression and how your results, do they match the results that people reported for these other devices? So I'm giving you one of my papers, kind of a fun system where we used a laser pointer pointing at the screen, like from the back of the room. You may be surprised to know that really didn't work out very well. And then a classic old paper, and we're not sure this is the one we're going to make you use. It's kind of intimidating because it's really long and full of math. You know, one of the old papers that right at the beginning of the mouse era where they discovered the mouse was pretty good input technique. And then for the final projects, we have a lot of ideas down on the web page, and they're back on the main project, on the main page at the bottom. And so I was kind of surprised. If you go to Wikipedia and look up scroll bars, it'll kind of tell you what it is, but it has nothing about the history. Right? It doesn't say anything about different kinds of scroll bars. If you look up Larry Tesler, there's virtually nothing there. If you look up some of these other people who've invented a lot of these interaction techniques, they don't have pages at all. I talked to a friend of mine who actually runs an online encyclopedia called interaction.org, interaction-design.org. I think I have that somewhere. And he said he would be delighted to put up any content that we have, you know, pictures of pages and so forth. I mentioned my video. That was from 1990. You know, in the last 25 years, there's been some changes in interaction techniques. You know, scroll bars are different. That was well before the handheld era, so there was nothing about handhelds in there. So it'd be a lot of fun to collect a bunch of new videos to add to that collection, to do an update, you know, all the new stuff about scroll bars since 1990, or the new stuff about, you know, clicking on things or whatever. So that's kind of the history concepts. Alternatively, another thought is to take a particular kind of interaction technique and do a very in-depth and valid comparison of different approaches for it. You know, so menus, scroll bars, or any of the things that we aren't using as homework. There's obviously in the homework, you're just going to do a small set of them. You know, maybe you could do a lot more. Alternatively, rather than picking a particular interaction technique, you could pick a particular device, like the iPhone or the Star or the Macintosh, and then, you know, talk about all the innovations. So, you know, this was a lot of work, a lot of articles about, you know, Steve Jobs and his contribution. It's a nice book about, you know, how Apple, you know, did stuff, and there's, you know, a little bit of information about what was on the Macintosh and on the Lisa and stuff. So, you know, there's starting to be some historical information about, you know, all the innovations, but no one's really articulated, well, this is new and this wasn't new, and this came from here, and this was brand new, and, you know, this guy did it, and so forth. So picking a particular system along the way and studying that in depth. It turns out a lot of the people who invented these things are still alive. So, you know, 1975, you know, it's kind of a long time ago. Probably most of you weren't alive then, but it really isn't that long in human lifetimes. So all of these guys, Ivan Sutherland, who you're going to watch in the 50s in the video for next time, is still alive. Alan Kay, David Smith, Larry Tesler, all these guys. Ted Selka, who invented the IBM pointing stick, actually works for CMU in the West Coast campus. So all these people are still around. I know a lot of them, and the ones I don't know, I know other people who probably know them. So we can create a record. And it turns out the HCM actually has an official site for interviews of famous old computer scientist people. And there's a format for official interviews. So if you wanted to make it, you know, on that site, that would be even better. And they have kind of a outline for what your interview should be like and so forth. And then finally, which I'm thinking a lot of the programming kind of people would be interested in, is, you know, invent a new interaction technique. It's really surprisingly easy to invent something new. It's not particularly easy to invent something new that's any good, right? So you can imagine inventing a new text entry technique or inventing a new way of, you know, selecting one of a set of objects. The trick is making it any good. You're not required to make it any good in order to get a good grade in the course, right? You just have to come up with something and do a valid test on it. And if it comes out worse than the status quo, well, you probably won't get a conference paper out of it, but you'll certainly get an A in the course. So the idea of this one is to take one of the areas that we're interested in and, you know, do some kind of implementation, prototype implementation of it, and depending on the sophistication of the technique, it's a level of programming that would be required. I'm sure anything you come up with would be fine to implement in Flash or, JavaScript or one of the prototyping environments, unless, we're not going to do this really elaborate speech recognition system or anything, because that's way beyond what we need to implement for this course. So mostly it'll be about kind of the prototype, designing a valid user study that compares it to something reasonable that's the status quo, and then seeing how it comes out. And if it is a new technique and it comes out better, then if you want to continue working over the summer and come out with a Chi submission or whatever for next year, that would be really exciting, and we'd be delighted to help you with that. And if you have your own idea of something relevant, Jeff and I will be happy to talk to you about it. And the thought is to do these in little groups, 2 or 3 people together. We haven't quite decided yet whether we're going to group you by topic or let you just pick your own groups. So if you have feedback on that, one idea that, like they do in some other courses, is that everybody submits what they'd like to work on, and then we try and pair them up. So people who want to work on the same kind of thing, we'll help you make those groups. That way, if you don't happen to know the other people in the class and there are 2 people who want to work on one kind of thing, we can help you get connected. So that's probably what we have in mind, but if you really want to form your own group with somebody and do something in particular, that'd probably be okay. So just as a quick poll, how many people think they want to do a history kind of project? 0, no, 2, okay. How many people think they want to do an invent a new technique kind of project? Okay. And how many people want to do kind of one of these in the middle? Okay. All right. That's kind of what I figured. It certainly sounds more exciting to try and invent a new interaction technique, and that's fine. And hopefully there'll be some people who will focus on some of this kind of historical part. Because I think it's really interesting, and it's really never been collected anywhere, and so there's certainly an opportunity to write articles that would be of interest to the world, and may turn out to be highly read on the web and so forth. Okay. All right. Any questions about logistics, topics, homework, anything like that? Okay. So I'm going to spend the rest of the time. So this class is 1:30 to 2:50, right? So we have about 50 minutes. 40 minutes, and I'm going to try and spend the rest of the time telling you why you should stay in the course and why interaction techniques are fun and appropriate to study. So the first question is obviously, what am I talking about? What is an interaction technique, and in particular, what is it not? And usually people kind of punt on giving a definition and just give examples. So an interaction technique are things like buttons and scroll bars and text entry fields, right? But they're also, and this is a, sometimes it's called the spin button and up and down button, whatever. That's checkboxes, right? So these are buttons. This is a pull down menu, right? So these are all widgets. But we're also talking about things like drawing new objects. So how do you draw a new object? How do you draw a new rectangle? That's an interaction technique. How do you select one and change its size and move it? That's an interaction technique. And if you think about selecting objects, the way that selection works in Microsoft Word is very different than the way it works in Excel. And that's very different than the way it works in a graphics editor. And it's also very different than the way it works in the Finder or the Windows Explorer when you have a list of files, right? So all of these kind of selection techniques are quite different across different devices, and so that counts too. Copy and paste is an interaction technique. Drag and drop, so there's a bunch of different things. One of the questions that's a little vague is how high level counts, right? So if a button counts, what about the scroll bar? Because the scroll bar actually has in it 2 buttons, right? So there's this button and there's that button. So what do these buttons do? If I click here, what happens? Say something. Okay, goes down by what? One something, right? So if it's text, it goes down by one line. If it's a graphics editor, it goes down by one something, maybe 10 pixels, some unit, right? And so this goes down by one, and that one goes up by one, right? But what happens if you click here? So this is called the thumb. Okay, what happens when you click on the thumb? Suppose you just click down and release. What happens? Nothing, right? But if you click and drag, that'll drag the text, right? So this is also kind of a button. It's definitely a different interaction technique than clicking on the endpoints. And who knows what happens if you click here? What happens if you click here? Okay. Any other thoughts? Right. So there's two different behaviors. In most systems, clicking in what this is called the trough, clicking in here jumps this down by one page. So it's kind of like this, only by pages. How many people didn't know that? Oh, there are always people surprised that that happens. In a few systems, but not very many, it actually moves the thumb to where you click. Okay, but there really aren't very many systems that do that anymore, because the standard behavior is that this jumps by pages. And if you don't believe me, definitely go try it for yourself. You can't really do this on the Macintosh anymore because all the scroll bars are gone, right? But on web-based stuff or anything, you can do that. Another high-level thing, so the scroll bar counts, even though it's made up of all these different buttons, right? On the other hand, the text editor, text entry field is obviously a widget, but Microsoft Word is not a widget. Microsoft Word is not an interaction technique, right? It's too high level. It has too much stuff in it. And you wouldn't really say that text editing in Microsoft Word is an interaction technique, because it's a whole bunch of interaction techniques all put together. And so it's a little bit vague about what should count. So I'm interested in your feedback on what you think would be some other good examples. And I meant to bring a pen. Hulu, it says. Hopefully that, oh good. So what are some other interaction techniques that you can think of besides the ones we just talked about? So we could put down a scroll bar and buttons. What else? Sliders. Checkbox. Just yell it out.
Pointing device.
Pointing device.
Eye tracking.
Speech. So speech recognition, right? Mm-hmm.
Accelerometer in a mobile device?
Sure. I'm sorry? Drag and drop, yeah. Mm-hmm. And we already talked about copy and paste. Sure. Double click, because that's used for special behaviors and lots of things, totally different than regular click. Great. Yeah, pinch and zoom, pinch for zoom maybe.
Is biofeedback one? Like, is the flex, with the snippet wristband or something?
Okay, yeah. I mean, in theory, you could use that to actually interact with something. Yeah, it's like, really? We haven't listed menus?
Hot corners?
Yeah, okay, yeah. So hot corners and edges for changing size and stuff. For resizing. Okay, great. Hover. That's good. I'm sorry? Switches, sure. Anything else? You wanna? I'm sorry? Press and hold, yeah. So lots of mobile devices which don't have a right button use press and hold for things. Well, we didn't even say typing. And then we have the keyboard shortcuts.
Temperature sensors?
Okay. Mhm. Okay.
Multi-touch gestures.
Yep, sure. Multiple fingers. Yeah.
Eye tracking?
We did that. Somebody. I'm sorry? Window interactions. So we have some of them down, but sure.
Do we have text menus?
So we have menus just in general, but obviously that's a really big category. There's context menus, drop-down menus, and a whole bunch of other different kinds of menus. Yeah.
We have motion sensing?
We had accelerometers somewhere, so that's probably the same thing.
We have gestures.
But we don't have gestures. And so there's a whole big category here. There's like flicking and then regular like circling, things like that. Okay. There's probably a lot more. What I have on this next slide is the list from Visual Basic. So if you bring up Visual Basic, these are the controls that it will let you just drag and drop into Windows. And some of these are the ones we just talked about, like buttons and text boxes. But they also have things like list boxes. These are menus, tab controls, date time pickers. So some of these kind of intermediate level widgets, like we talked about, do these count? Obviously, a date time picker is a whole collection of other things, but it certainly kind of makes sense as an interaction technique. Scroll bars, timers, that's kind of a behind-the-scene thing. If you want something to happen, you might put that in. So there's a whole bunch of kind of more conventional Windows kind of widgets that we didn't mention. Some of these are just specializations of the ones we did. And then somebody talked about physical buttons, but if we're going to talk about devices beyond the computer, then, and even like smartphones have a variety of different physical mechanisms on them. And so, how do you interact with your camera? There's all sorts of special widgets people put on things. This is a stupid design for a phone. It was a total flop. Who knows what this is? From BlackBerry, right? So this is a BlackBerry. The original BlackBerry had a scroll switch on the side when they had all sorts of innovative stuff for when they started in terms of how you could use only a little roller ball, a little two-dimensional roller. But then they made it a one-dimensional roller. Then they made it into a two-dimensional little ball, a pearl they called it, and you could select things with that. So, these are physical switches, there's a light switch, right? So physical controls count too. My video was called All the Widgets. So widgets is another term for these kinds of things. And if you look it up on Wikipedia, it's surprisingly, interaction technique and widget are both there, but they don't refer to each other. So they were clearly written by different people. And you should go and look at these definitions and you see if you think they're required, describing the same thing or not, or whether they think there's something different about it. On the other hand, people are using the word widgets to mean these kind of fairly large-scale apps that kind of work in the background or aren't separable. So Apple has this thing called dashboard widgets, and I think Google Chrome has widgets, right, that you can put on your screen, and that's not what we're talking about. Because it's really not the same as an interaction technique that goes across lots of things. And there's some more vague terms for them, like elements or components. Windows calls them controls, which is a pretty good name. Sometimes you might call them behaviors. But trying to come up with a really formal definition is tricky. So I tried my own definition. An interaction technique starts when the user does something that causes the computer to respond and includes the direct feedback from the computer to the user. Interaction techniques are generally reusable across various applications. So I don't know, kind of wordy, not that excited about this definition, so hopefully by the end of this class we'll come up with a better one. Wikipedia defines it as a user interface technique or input technique is a combination of hardware and software elements that provides a way for computer users to accomplish a single task. So that's kind of good. It gives you the sense that, you know, it's doing one thing, so scrolling is picking a position in the document, the date picker is picking a date. But, you know, if it was two tasks, you know, does that mean it's not an interaction technique anymore? Foley and Van Dam said it was an interaction technique as a way of using a physical input-out device to perform a generic task in a human-computer dialogue. So we talked about Word and dashboard widgets not being interaction techniques. I think both of them fail on the concept of, you know, it's only does a single thing, you know, it's not reusable across applications and so forth. And also I'm probably not counting visualizations. So a visualization is a way of presenting information so it's clearer, typically with graphics. But it doesn't, visualization all by itself doesn't necessarily have any way to interact with it. So if you have a visualization that has behaviors, well then maybe it counts, maybe it doesn't. But so I'm trying to think not visualizations by themselves, and similarly not animations or movies by themselves to the extent that they don't have any behavior. Yeah?
Would you categorize Windows 8 live tiles as an interaction technique?
Yeah, probably. So it's basically a technique, it's kind of like an icon, right? So it's a thing that appears on the screen, and there's a certain behavior that you can click on it, right? Is there something else you can do with it besides click on it?
Basically, but I think
Right.
it's a little more sophisticated than I'm finding.
Yeah, so I mean, icons are an interaction technique that go way back to the beginning of window managers. Live icons, live tiles are basically a kind of live icon for applications. But, you know, so it'd be fun to try and think of different things and push on these definitions to see if maybe we need to change the definition because it doesn't include this thing, or it's not clear whether this counts or not. So why are we studying interaction techniques? What's the point? One is obviously they're used extensively. Everybody's use of technology of all types, you know, not just computers, but phones, DVRs, televisions. Pretty much everybody uses interaction techniques. You know, my television at home now, my wife can't use it anymore because there are all these weird interaction techniques. It's not just an on button, but you have to push and hold it for a while to make it go off. And if you wanted to change the channel, you actually have to push it in and pull forward and then release. So, you know, interaction techniques are all over, not just in computers. And then certainly everybody's using computers, and so, you know, you can certainly imagine that that's important. I think they're very interesting historically, and they haven't been studied very much. You know, it certainly has an enormous impact on people. I think it's kind of interesting to think about, you know, why do we do things the way we do? Is there a good reason for it, or is it just what somebody happened to think of and everybody decided to copy that, right? So certainly the way scroll bars work is pretty much the same way they worked on the Macintosh in 1984. Why do they work that way? Is it just because Bill Atkinson and Steve Jobs and Larry Tesler decided to do it that way, or is there a good reason for it? You'll probably learn along the way a lot of tricks that you didn't know worked that are actually built into all these techniques along the way as well. So one example is the arrow on the scroll bars. So we talked about the scroll bars before. The one on the right is the original Macintosh or Lisa scroll bar. There's an arrow at the top and the bottom. And notice that this arrow points down and this arrow points up. Right? So when I click on this bottom arrow on either of these, the same thing happens, which is what? What scrolls down? The page scrolls down. So when I click on the bottom arrow, the page goes down. Right? No, that's not right. The page goes up. Right? So if I click on this arrow, which way is the content going to go? Content goes up. I mean, the content goes down, right? Wait, right. Content goes down. The page goes up because we're going to the end, right? But the actual flow of the document, if you look at the document, it's flowing down towards the top, right? So when I click on the bottom arrow, the view you get is of the document going up, all right? And this is just so familiar to us that we don't even think about, anybody remember what slide number we were on? We don't even think about how strange it is that when we click on the bottom arrow, the text goes up. But the little bar, the box thing, goes down, right? And so back in the days of the star, the original scroll bars, they thought they should show you which way the text flows when you click on this arrow. And then when when Apple decided to redesign it, they decided they should show you which way the little box goes and which way you think of the document going. So we're going towards the end, which requires that we go flowing in the opposite direction. So why is it one way versus the other? Is one way better than the other? Is it clearer to people? Does it have more connection with what you're doing? Would anybody care if we switched them? So these are some interesting kinds of questions. It might just be taste. It could be something aesthetics that really has no impact on performance, or it could have a big impact on novice performance, but nothing on experts, or there are all these kinds of issues. Another important reason to study interaction techniques is they really are being invented all the time, and even in the commercial world. Bas Ording is a longtime Apple employee. He actually was responsible for the dock and the way it gets bigger, as you're moving your cursor around. But then he moved to the iPhone team, and he's responsible for the way you flick and the text moves. So what happens, everybody pull out your iPhone, or if you don't have an iPhone, your Android phone, and go to something like Contacts, right? So something long list. And when you get to the very end of the list, what happens? Okay? So scroll such that you get to the very end of your list. What happens if you have an iPhone? It bounces. Is that what you meant? Yeah. So a clear way to say it is it bounces off the end, right? And you get this little animation. Who has a Samsung phone? Anybody? Okay, what did yours do? Right. So it doesn't bounce. It used to bounce. If you had your phone 3 years ago, it would have bounced. But they lost $1 billion lawsuit to Apple, and now it glows blue instead. Yeah?
That's a standard Android thing. Samsung.
Right. Okay. So any Android phone now is going to glow blue instead of bouncing. Okay. And so this is a big difference. It turns out, as we're going to talk about in the next slide, it's worth a lot of money. Another technique that's fairly new is this pull down to refresh. Okay, so that's an interaction technique. It was invented by Twitter as late as 2010. So it's only 3 years old in terms of its invention. The patent was released then. And now you see it everywhere, right? So presumably, Apple has licensed this idea from Twitter. And that's why they're using it, all over the place, right? Facebook, Apple, everybody's using this now, right? So you don't need this, little icon for refreshing because everybody just knows how to refresh. So this is an invention. It's 3 years old. Now everybody in the whole world is using it. Yeah. How much should something like that cost? I have no idea, and you probably won't be able to find that out. But in terms of this lawsuit, if you've been following the Apple and Samsung and Apple and everybody else and everybody else and everybody else lawsuits, their interaction techniques are really, really valuable. The Apple lawsuit to Samsung that was settled in California for $1.05 billion was on 5 different patents, one of which was the bounce scroll. And so it's, as far as I can tell, there is no breakdown of how much each of those patents contributed to this $1.05 $5 billion. But you know, if it was half for each one or a fifth for each one, then it's $200 million is the economic value of this particular little invention. I don't think it makes any sense that that's what it's valued at. And I'm sure that's not what people are paying Twitter for the refresh thing. But you know, you've got to imagine it's worth you know, the amount of money they spent developing it. Yeah.
So I have a Windows phone, and it actually does bounce, but it, instead of bounce, in addition to a bounce, it kind of like compresses the content, kind of like squishes it as,
Okay.
as it overshoots. And so like it's slightly different, but it still seems like very similar, and it makes me wonder why Apple doesn't like go after it.
Apple and Microsoft have have way back in many years ago in the 80s, 90s. Apple and Microsoft had a little fight, and this was when Apple wasn't doing very well. And Microsoft decided it was in their best interest for Apple not to go out of business, and so they entered in a cross-licensing agreement that Apple and Microsoft, from that time forward, cross-licensed all of their inventions to each other. And so Microsoft is allowed to use anything Apple has and vice versa. And I don't know how much money it involved every year, but you won't see Apple and Microsoft suing each other. So that certainly could be one reason. Whether that particular behavior is actually covered by the patent or not, you know, that's an issue that we'll talk about later in terms of intellectual property and, you know, how close does it have to be and things like that. But it's most likely would have been covered, but it doesn't matter because Apple and Microsoft are nice to each other. Another reason to work on interaction techniques is that it's actually a very active area of academic research. And if the main academic conferences in the user interface area that focus on interaction techniques are the big CHI conference and a smaller conference called User Interface Software and Technology. The next User Interface Software and Technology conference is in Hawaii next October. And the deadline's in April. So if you're really quick, you can, you know, get a paper into WIST and go to Hawaii next fall. I'm thinking of going myself. I'm sure Jeff's planning to go. Last year it was in England, so you get to go to nice places if you get papers in these conferences. CHI this year is in Toronto. It's too late. All the papers were due in September. Next CHI is in Seoul, so that's also a cool place to go. And the deadline for CHI is in September, which is a little more plausible if anybody invents anything cool. So how many new interaction techniques do you think there are in CHI? Maybe 8, 2 sessions worth? So probably the CHI has a rejection ratio of about 5 to 1. So if there's 6 interaction techniques in CHI, that probably means 30, you know, pretty reasonable inventions were made every year that people submitted to CHI, and some were, you know, over threshold and got in. So there's definitely a lot of work in this area every year, and you know, some of it has had an enormous impact. And there's certainly a big need for it. You know, it's not the case that we're doing things the best way we can. Everybody still hates doing text entry on their phones, right? So people are still using their laptops here. I don't see anybody trying to take notes on their phone or on a even on a tablet. Anybody have? Are you using your tablet to take notes or?
Not right now, but I could.
Yeah. So you have a stylus? Yeah. So I tend to handwrite on my phone, but how many people like handwriting? Most people in your generation and younger don't handwrite anymore. Well, you have some art students, so that's probably not fair for the population at large. But so, you know, what is the right interaction technique for doing text entry on devices? And I think that's still a great area for research. The desktop metaphor that we're still using, you know, with a bunch of icons on the screen that we use on the iPhone and the Samsung and, you know, regular computers, hasn't really changed in 30 or 40 years, and that's pretty sad. And, you know, it's really awkward on phones and devices to select a single character. I'm continually annoyed by trying to select, you know, the URL or something, copy and pasting it is really awkward. So there's certainly lots of need, lots of opportunity for improving things, and, you know, imagine the impact you could have if it's accepted. Certainly consumer electronics is a big problem. This is an article, I love this. It's 1991, right? I can't work this bleep thing. And it talks about how from VCRs to television, copiers and microwaves, poorly designed machines, cluttered with unwanted features are driving consumers crazy. Whatever happened to user-friendly? So suppose they were going to update this article today. Do you think it would be different? Well, certainly. We're not going to have VCRs here anymore. Nobody has to worry about their VCRs, right? Everything else is identical, right? The copiers of today, are they so much easier than the ones of the 90s? It's pretty much the same stuff, right? It's a little easier to program your DVR at home because you get to select which show you want to see. But if you want to do it by time, it's done exactly the same way it always was. Blinking 12s, well, we don't have that anymore because all of our devices are connected to the internet, and so they set their own clocks. But when you go to a hotel, how many people don't bother with the hotel in the hotel's clock because you're sure you're going to screw it up, right? So setting clocks, what could be easier than that, right? There's two things you have to do. Pick an hour, pick a minute. And yet, we're not going to do that on the hotel clock because we're going to screw it up, and then we won't wake up in the morning, and that'll be a big problem. So, appliances are still too complex. This is a picture of Randy Pausch, who unfortunately passed away a number of years ago, destroying a VCR, which he used to do in the beginning of his classes to kind of channel consumer frustration at the quality of consumer electronics. These are the remotes I have at home, right? And I'm sure if you tried to collect all the remotes you have, I mean, the stupidest devices come with remotes. My monitor comes with a remote. It's like I'm never more than 3 inches, 6 inches away from this thing. Why do I need a remote? Pretty silly. So why are interaction techniques so hard to design? Why is it that we're having such a problem with this? Well, it turns out there are a surprisingly large number of design choices that you have to make. And there's lots of trade-offs in how they want to work. Are you trying to make it efficient for experts or understandable by novices? How would you trade that off? Do you have to deal with a small number of things or a large number of things? Just as by way of an example, if you move a mouse on a table, how far does the cursor move? Right? So an obvious thing is if I move the mouse an inch, the cursor moves an inch. That seems really understandable. Turns out it's nothing like that. In fact, it's not even linear. If you move the mouse fast on the desk, the cursor actually moves faster per inch than if you move slowly. Right? And so there's this curve, a fairly complicated mathematical curve that maps the speed of the mouse and the point of the mouse to the cursor movement. And we're going to go into this detail. We're going to study this in a little more detail in a future lecture. And how far does the content move when you flick your finger? Or if you think back to the original iPod, one of the reasons the iPod was so successful, remember it had a little dial, right? And it turned out all the devices before that had an up arrow and a down arrow, an up button and a down button. And so one of the things that the iPod innovated on was that you had this dial. How far did the content move when you spun the dial? Again, it was adaptive. If you spun fast, the content would go really fast. And the same thing's true when you flick your finger. If you move your finger slowly, the content stays under your finger. If you flick it, one of the things that Apple has done really effectively is make it so you can go through 10,000 contacts on a phone by flicking your finger really fast. Right? 10,000 contacts, you can actually get to the end of it. Otherwise, you can imagine it would take forever if you just had to use an arrow key 10,000 times or something, right? And so all of these devices, all of these interaction techniques have a fairly sophisticated algorithm behind the scenes that is doing things in a very effective way. So right after the iPhone came out, Nokia came out with a clone, a copy, that tried to be an iPhone copy. And sure enough, Apple sued them. But I got one of these Nokia phones, and it was just awful, right? So you flick your finger, and it would be like, it didn't work. Or you would try to log in by, swiping across, and it would be kind of weird and not working. And you tap on it, and it just just was bad. And basically what the difference is that they just had a bunch of programmers hack it up, try and copy the general idea of the iPhone, without actually doing the work of understanding exactly what these algorithms should be. And so Apple has put an enormous amount of effort and good HCI practice, good software engineering practice, into making all these behaviors seem fluid and effective. And if you tried to reproduce it, you would discover it's really not so easy. And it's kind of the general HCI principle of, it's easy to do things hard and it's hard to do things easy. But there's, really good evidence that that's happens all the time. Another issue of complexity is how many different behaviors are actually embedded in what seems like it should be pretty simple. So let's take a checkbox. Imagine this is a checkbox. And think about what are the different states or modes that it can be in, right? So to give you the one right off the bat, what is the first choice with a checkbox? Louder? Yeah. Checked or not, right? So that's two choices, whether it's checked or not. Now, a checkbox, a real checkbox in one of your applications, like in Macintosh or Windows, what's something else that a checkbox responds to?
Well, it can have focus.
Right? So it can have the mouse, it can have so which focus are you talking about?
Keyboard focus.
Right, so it turns out in Windows, and I don't know if the Macintosh does this, you can tab from widget to widget. And that outlines it, typically with an outline, sometimes with orange or something like that. That will determine whether it's keyboard focus. And if it has the keyboard focus and you hit return or enter or space, then it'll move which one is checked or not. Totally independent of whether it's checked or not. So that's already 4 states. What's something else? What? Enabled or disabled. It turns out that that is, in fact, also independent of whether it's checked or not. That, it can be grayed out. But it turns out it can be grayed out whether it's checked or not. Usually it would be not checked when it's grayed out. But it is possible in some situations to say, you are not allowed to change this. This is selected. And so the widget, as part of its fundamental design, allows it to be grayed out while it's selected. Yeah?
Now there's also the select all checkboxes where if you have only some of the items checked,
Right.
that'll be a square.
Right, good point. So it's actually a third option, which is ambiguous, right? Some are, some aren't. So if you have multiple objects selected, say this is bold, and you have some text and some text that's bold, and you select both of these, then the checkbox will have this little thing, which is sometimes a square, which says some are and some aren't. Or I'm not going to change it, is another thing. So if you have a bunch of things and you want to apply, you can sometimes get your... So all of these actually now have 3 choices, not 2. Okay? So this one's grayed out. Okay, what else? We talked about it before. So, Hover, exactly. So another row is whether the mouse cursor is over it or not, okay, without pressing the button down, right? So you can't actually hover when it's disabled. So when it's grayed out, that is actually not possible. But these two are totally independent of hover. So you can have hover while it's dotted or not, and you can have it whether it's checked or not, right? So hover, I move the mouse over it, don't click down. That's a hint. What's another one? Yeah?
While you're pressing it down?
Right. So when you press the mouse button down, many widgets will look different than when you're hovering over them, right? So if I push my mouse down here and release it, becomes checked, right? That's pretty straightforward. So if I go down here and then I release it here, that's how you get it to change state. But what happens if I push down and move outside? So, whoops. So I'm hovering. I hover, I press down, now I move the cursor so it's outside of it. What does this do? Huh? Nothing? That's incorrect.
Doesn't it drag slightly? Like,
No, drag slightly is incorrect as well.
can you contextual help?
No, you don't get help.
Change active and then if you move out, it won't be selected.
Right. It turns itself so it's no longer hovered, no longer selected. It turns off. So, and if I release here, what happens? What happens if I press inside, move outside, and release? It doesn't change state. Now, it's different than saying it becomes unselected, right? So if this was selected, and I press down inside, move outside, and release, it stays selected. And similarly, if it was not selected, and I press inside and move outside, it stays unselected, right? So it's just aborts. So this is an abort, basically. Now, if you ever try to implement your own widgets, or if you go to widgets that are implemented in Flash, like people just making their own, you'll see that almost everybody forgets about this one. And so you get into this stupid state where the mouse is actually up, but the widget is confused. And it thinks the mouse is still down. And so all this stuff is happening. And I always get messed up with Google Maps. If you try and pan, especially like in the view where you can, the street view. So go into street view, press the mouse down in the window, move outside the window and release, and it still think you're panning around and you can't get out of it. Because everybody forgets about this. So 1, 2, 3, 4, 5. It's basically 3 to the 5th different possible states, right? There's an enormous number of combinations of all these things together, because you can pick one of these and one of these and one of these and one of these. They're all totally independent. And if, as a graphic designer, you have to figure out, well, what does it look like when I press inside and I move outside, or when I press inside, when I hover and it's disabled, or when it has a focus and then I do this. And some of these are allowed and some are not allowed, and your code has to handle all of them independently.
Isn't there also the question of what ambiguous does when you click on it, whether it goes to yes or no?
Right, yeah. So which one does it go first? And so I have some of these here. I have 2 to the 4th times 3, but it could be even a bigger number than that, of the different combinations of all these things together. So these are most of the ones we talked about, some we didn't think of. So other widgets also have a lot of these things that people don't think about. If you're creating a new object and you press down and move and release, you get the object, right? What happens if you press down, move down, then move up and cross over where it used to be? What happens? Does it flip over? So now it's upside down, which doesn't make much of a difference for a rectangle, but might make a difference for a text box, like you get upside down text. What about for windows? If you take a window and you start dragging it and then you drag it up here, what happens? Anybody know? Do windows flip over if you go past the start point? Anybody know? The answer is no. They have a minimum size. So they don't flip over. But graphical objects usually do. Right? So if we go into PowerPoint and we insert a new object, insert a shape. So if I go down, that's fine. If I go up, it's fine. It doesn't really care. But if you try and do that for a window, well, this one's kind of not at the bottom, right? So it won't let you make it smaller than some minimum size. Oops, I didn't want to do that. Wake up. So you've got interaction techniques. We're going to talk about how you measure them, and that's going to be one of the topics of the next week. The next lecture is quality metrics and evaluating them. We have all of these measures that are the same as other HCI measures, efficiency, learnability, aesthetics. And another important criteria, of course, is how generalizable they are. So can you make a scroll that works for 5 things and 50,000 things? You want to take into account people as well as devices. So, what can people do? How big is your finger? You have to deal with the look. What does it look like, as well as the feel? How's it behave? There's a lot of work on affordances, which we won't talk about too much, but it's basically make the idea that if a user looks at it, they know what to do with it. So the knob, you're supposed to turn it. This doorway, you're supposed to push on it. And this is ambiguous. That's why it has a label, because it looks like it's a handle that you'd pull, but in fact you're supposed to push. So that's the idea of affordances. Don Norman has a lot of great stuff about that. Okay, so hope everybody's interested in taking the course. If you're not, feel free to go ahead and drop it quickly so we are clearer about how many people are going to actually be in the course. If you aren't registered officially and want to be, let us know, and we can certainly handle that.